Alright, so here is the wave and sound review. Number 1, when the particles of a medium are vibrating at right angles to the direction of the energy, the wave is a transverse wave. Draw a transverse wave and label the parts. So a transverse wave, again, like it said above, travels at 90-degree angles, so that means it just goes up and down. So that is what a transverse wave looks like. And the parts of wave, so the very top would be a crest. The very bottom is a trough. From this midpoint to the crest, this distance would be the amplitude. And then from crest to crest would be wavelength. Number 3, draw a longitudinal wave and label the parts. So longitudinal wave, they're harder to draw just because the particles are close together, far apart. So whenever the particles are far apart, we call those rarefactions. So again, that's right there where the particles are far apart. When the particles are close together, those are compressions. And then from compression to compression, that distance will be wavelength. Number 4, below is a number of series of waves. Underneath each diagram, write the number of waves in this series. So again, in order to count transverse waves, you start where the wave is, and you need a crest. So that's a crest, and you need a trough. So that right there would be considered one wave. We have a crest and a trough, and we started and stopped at the equilibrium point. And then we have one crest. So that would be 1.5 waves. We start here, we have a trough, and we have a crest, and we stop. So that would be considered one wave. Start here, we have a crest, we have a trough, we end. So that's 1. We have a crest, and we have a trough. That's 2. And then just the crest, so that's 2.5. And if we just have one crest, that would be just half a wave. Number 5, the number of cycles of a periodic wave occurring per unit of time is defined as frequency. So again, that's just the number of waves occurring per unit of time, and that unit of time is usually 1 second. How are frequency and wavelength related? They're inversely proportional, meaning the higher the frequency, the lower the wavelength. And then if we have a low frequency, that means we have a very high wavelength. So I'm going to draw a picture for that. So a high frequency and a low wavelength. So our wavelength is low, meaning it's small, and that means that these waves would pass more frequently. If we have a high wavelength, meaning our wavelength is very long, our frequency would be down, meaning these waves would not pass as frequent. Number 7, a wave travels at a speed of 654 meters per second and has a frequency of 22 hertz. What is the wave length? So again, when we look at these formulas, velocity will be on top, wavelength and frequency will be on bottom. We are looking for our wavelength, so we see it will be velocity divided by frequency. So our velocity is 6 54. And our frequency is 22. Divide those two numbers to get 29.72 meters as your answer. Number 8. What is the frequency of a wave that has a speed of 0.4 meters per second and a wavelength of 0.02 meters? So again, looking at what we're trying to find frequency. It will be velocity divided by wavelength. Our velocity is that 0.4 meters per second, and our wavelength is 0.02 meters. Divide those two numbers and we get 20 hertz as our answer. Number 9. A pendulum makes exactly 40 vibrations in 20 seconds. Calculate the period. So looking at this triangle we learned yesterday. So we have frequency equals 1 divided by the period, or the period equals 1 divided by frequency. So in this one we have the number of vibrations per unit of time. So we can find our frequency, 40 vibrations over 20 seconds. So the frequency would be 2 hertz. And then we would plug this number in to find the period. So our period, which we know is time, is 1, just the number 1, divided by 2. So 0.5 seconds would be your time. Number 10. What would the frequency be of a wave that has a period of 0.005 seconds? So we've given this, we want to know the frequency, so it's going to be 1 divided by that period. Our period is 0.005, and that's going to be 200 hertz as our frequency. Now we're going to go into the fill in the blank part. It says if the frequency of a wave is doubled and the speed remains the same, the wavelength will half. This is because frequency and wavelength are inversely proportional, like we said up here. So if you increase one, the other one will decrease. If you decrease one, the other one will increase. So we doubled the frequency, meaning we will do the opposite, meaning half the wavelength. Sound travels fastest in solids and slowest in gas. And again, that is because of the particles. In a solid, the particles are very close together, so they allow that sound to bounce off and transfer quickly. In a gas, those particles are just floating around, and it takes a while for that energy to pass through those particles. Which type of wave is a sound wave? So it's a mechanical wave because it needs a medium to travel through, but more specifically, it is a longitudinal wave. What is pitch and what happens to pitch as frequency increases? Pitch is how high or low a sound is, and the pitch will increase. So again, if we have looking at two different waves, we have wavelengths here. So this means that the frequency in this one increased, and that would cause it to sound like a higher sound. What causes the Doppler effect? It is the movement of a sound source, the listener, or So again, that's if a car is driving this way and you're standing on the side of the road. It's going to sound like a high pitch sound because the waves are getting compressed and causing the frequency to increase, which would cause the pitch to increase. If you're over here and the car is going in the opposite direction of you, so it's going away from you, those wavelengths would be longer, causing the pitch to sound lower. So let's look at this fill in the blank. Waves carry energy. The two types of mechanical waves, so again, mechanical waves mean that they need mediums, solid, liquid, or gas, to travel through, and that is transverse and longitudinal. The blank of a wave is the number of waves per unit of time. That would be frequency. And the distance from crest to the next would be wavelength. True or false? The unit for frequency is hertz. That would be true. 21. The number of waves generated per second by a source is called the frequency. That would be true. And doubling the frequency of a wave would cause the speed to double. No, that's false. The only way that you're going to change that speed would be changing the medium. Matching the lowest point between each crest of a wave would be D, the trough. A wave in which the particles of medium vibrate parallel to the path, that is going to be B, longitudinal wave. 25. A substance through which a wave can travel, that will be F, medium. 26. A wave which needs a medium to transfer energy, that is going to be A, mechanical wave. 27. In a longitudinal wave, the measure for the density of the compressions would be C, the amplitude. And 28. The time it takes for one wave to occur, that would be E, period. And finally, we're at the matching. If a wave had a low frequency, what would be its wavelength? And that's going to be A, long. So low frequency, meaning the waves do not pass as frequent, so the wavelengths would be long. 30. If the amplitude of a sound wave is high, that means the sound has a C, high intensity. 31. Frequency can be found if, and this answer is going to be both A and C, you know the speed and wavelength, or if you know the period. And again, in order to find that frequency would be velocity divided by the frequency, or 1 divided by the period. 32. The symbol lambda represents blank in the wave equation. That would be C, wavelength. 33. The motion of either the listener or the source of the sound causes the Doppler effect. 34. During the Doppler effect, the blank of the wave increases as the object gets closer. The frequency gets increased. And 35, the frequency of a sound wave determines what? And that would be the pitch. A. And that is it for the wave and sound review.